Hi, everyone. Depending on what day it is, if you're watching this on Tuesday, that would be second or fourth hour. Happy almost Pi Day. But if you're watching this in seventh hour on Wednesday, happy Pi Day! Woohoo! So that's an exciting day. And to celebrate, we're going to take some notes over section 2.7 on solving polynomial inequalities. Good times right here. So, again, gonna just go with the written notes here and see how that goes for us. So, we're gonna start this section. Let's see if I can make this work the way I think I can. I don't know, you guys. Okay, here we go. Okay, section 2.7, polynomial inequalities. Here we go. So let's kind of keep in mind what is an inequality. So if we're trying to solve some sort of inequality, or we're saying that x is greater than 5, then we know that there are lots of numbers greater than 5. And so the answer to our problem would always be an interval. And so when we're solving polynomial inequalities, we're always going to have an interval. Okay? So we're going to think about some polynomial graphs. We've talked about polynomials before, and let's remember polynomial graphs are smooth and continuous. So here are some samples of polynomial graphs. Remember that you can pause the video if you need time to draw them or write down anything that we've missed already. And then we're going to talk about how polynomial inequalities actually come in a few different forms. We can either say that the polynomial is greater than 0, the polynomial is less than 0, it's greater than or equal to 0, or it's less than or equal to 0. Okay? But what does all of that mean? Well, if we're talking about a polynomial function that is greater than 0, we're trying to find out where is the polynomial positive, or in other words, where is it above the x-axis? And so if I look at these graphs, I can look at like this first one. Let me zoom in. This is the way we zoom. I'm trying to find out where is this polynomial above the x-axis. Well, it's above the x-axis right in here. Okay. On this one, I've got two different pieces that are above the x-axis. Over here, we've got a little tiny piece that's above the x-axis, and then this larger piece over here. And on this last one, we've got, again, just a few little pieces that are above the x-axis, okay? So that's where the polynomial is positive. When the polynomial is less than 0, we're trying to find out where is the polynomial negative, or where is it below the x-axis. So again, looking at these samples, right, where is it below the x-axis? Over here and over here. On this one, it's right here in the middle. We're below the x-axis. Here, we're here and a little piece here. Over here, there's a few little pieces that are below the x-axis. That's what we're talking about. And then the other ones are then pretty self-explanatory. Where is the polynomial greater than or equal to 0? Where is it above the x-axis, or where is it actually on the x-axis? Okay, so that's going to be important. And finally, if f of x is less than or equal to 0, I want to know where is the polynomial negative, or where is it equal to 0, meaning where is it below the x-axis, or where is it on the x-axis. Okay, so we have, so we'll notice that the polynomial functions change from being above the x-axis to below the x-axis, or from positive to negative at the x-intercepts. The zeros, because that's what x-intercepts are going to be what we call our boundary points when we're solving these inequalities. So here's the general method for solving polynomial inequalities. Step number 1, express the inequality with 0 on one side, meaning that we have to have it where everything is on one side, and on the other side we have just a 0. We can't have any other numbers or terms. Then we're going to solve the equation f of x equals 0. So again, thinking about finding zeros, the solutions are going to be our boundary points. Then we're going to put the boundary points on a number line and determine the intervals that we're dealing with. And I think the number line is a nice visual to help us kind of figure out, like, to see, like, what are the intervals that we're talking about. Step number 4, choose one representative number called a test value within each interval. Then you're going to go back and you're going to evaluate the function at that test number to determine if it is positive or negative. Okay, one of the things that we know also by looking at these graphs is, for instance, on, let's just go with this one. Okay, if it has a 0 here and it has a 0 here, everything in between there is going to be either positive or negative. It can't be some positive and some negative, or else it would have crossed back over the x-axis. So we use those intervals and a representative value within the intervals to help us know if it's positive or negative. Okay. Next, we're going to make a sign chart. We're going to do that actually on a number line. So the ones in the book look a little bit different. I'm going to simplify it for us, and we're going to do those on a number line. And then we're going to state the answer as an interval, or it might be several intervals. So let's look at some examples. Let's see here. What do I have? Let's do this. Sorry. Yeah. We're going to start with, this one. Okay. So we have x cubed plus 3x squared is less than or equal to x plus 3. The first step is to make sure that we have that with 0 on one side. So I subtracted x. I also subtracted 3. Oh, that's not the right one. Look, that says number 2. Let's start with an easier one. I apologize. We're going to come back to that one in just a moment. Let's look at this one first. Here we go. We're going to solve. And we're going to, again, make that, so we have 0 on one side, so we'll subtract 15 on both sides. Okay. Then we're going to be solving this equation, this polynomial equation. We're going to do that by factoring. When we factor that, we get 2x minus 5 times 2x plus 3, or times x plus 3. That's equal to 0. We set each of those factors equal to 0, and we solve them, and we get these values. X equals 5 halves, and x equals negative 3. Okay? Now, we're going to make a number line, and we're going to put these boundary points on the number line. It looks like this. Okay? Then, I'm going to determine the intervals. Now, in looking at that, we can start over here on the left, okay? And I'm thinking about what's the lowest number down here? It's negative infinity up to negative 3. This is a boundary. We have to stop there. Then we go from negative 3 to 5 halves. Then we go from 5 halves to infinity. So here are our boundary point, or our intervals that we're talking about. Okay. We're going to choose a representative value within each interval. Now, this is where it gets kind of interesting. Don't be ridiculous. Okay, that's my advice there. We don't need to choose some number that's like super close to negative infinity, right? In fact, I'm probably going to choose something that's just right inside that interval, like x is negative 4. Anytime I can, I'm always going to choose 0 as one of my test values. And then here I'm going to choose again something that's just inside this interval. I don't need to choose something like 587. That would be silly for us to try to calculate, and there's no point to that. I just need to work with some numbers that I can deal with. So we go back to our function, okay, and we're going to plug in those values. And this is actually kind of interesting because ultimately I don't care what the answer is. I only care if the answer is positive or negative. So as I'm working through those, maybe at some point I don't even really care so much. Like for instance here, I've got 2 times 16. I know that's 32. I'm going to take 32, and if I subtract 4 and subtract 15, I'm relatively certain that that's not going to be less than 0. So I'm going to get a positive number. The same thing kind of over here. I've got 18, I'm adding 3, and I'm going to subtract 15. I know I'm going to get a positive. Here, putting zeros in for x's, we get zeros, and then minus 15, which is negative. So I haven't even calculated the actual values there. I've only decided whether or not the answer would be positive or negative. Now, normally you would just go back to your original number line and put these signs on the number line. I made a new number line so that I could kind of show the progression here. So here's our number line. Now this is what we might call our sign chart, okay, where I'm saying, okay, well, here's what I know then. Everything from negative infinity up to -3, any number I choose in there is going to give me a positive value. Any number I choose between -3 and 5/2 is going to give me a negative value. And any number I choose from 5/2 all the way to infinity is going to give me a positive value. Now, go back to our original problem, which said, I want to know, where is this function greater than 0? It's greater than 0 when it's positive. Where is this function positive? Well, it's positive in this interval, and it's positive in this interval. So I write that answer as a pair of intervals unioned together. Okay. Now we'll move on to the second example, which you already kind of saw. Okay, back to example number 2. We already talked about getting 0 on one side. So we subtracted x, we subtracted 3. Then we're trying to really solve this equation, and I kind of started to factor at the same time, knowing I'm going to need to do some grouping. X cubed and 3x squared have an x squared in common, with x plus 3 left over. Negative x and -3 have -1 in common with x plus 3 left over. We factor, we would set each of these factors equal to 0, and we would get these values. Okay. Now, I made my number line, here it is, with my boundary points on it, -3, -1, and 1. But look at my intervals. My intervals are a little bit different this time. And the reason is that, look back at our original problem, we're trying to find out where is x less than or equal to. Okay. Well, I'm going to use a bracket to indicate the equal to part. Okay, so that's going to be something that's a little bit different between these first two examples. Then we choose a boundary point within each interval. So here I chose -4. There's really only one kind of decent number to deal with between -3 and -1. That's -2. Then we have between -1 and 1, again, I would choose 0 if you always choose that one when you can. And then between 1 and infinity, again, just choose something reasonable like 2. Now, this is going to be kind of interesting also. You're going to notice, and I started on over here for x equals -4, okay? And I said, okay, I'm going to go back to actually the factored out form. And I'm going to show you why that's going to be the easiest thing to do. I could write it all out like this, -4. Here, let's see if I can zoom that in. -4 plus 3 times -4 plus 1 times -4 minus 1. And again, remember that when you're testing these values, we don't care what the actual numerical answer is. We only care if it's positive or negative. So I'm just going to worry about whether or not each factor is positive or negative. And in fact, let's see. There we go. Over here, we can see that we've got, this would be a negative times a negative times a negative. Well, negative times negative times negative is negative. Here, if I think about x is -2 and I go back up here, well, -2 plus 3, that's positive. Oh no, that's my husband calling. I need to talk to him very quickly. Hang on. Hello?
Hey, what's going on?
Not much. You're on speaker and I'm making a video for pre-calculus. Would you like to say hi?
Hi, everybody. I know my wife's a hard teacher.
That's funny. Hey, so can I call you back when I get done with my video?
Yeah, it's fine.
Okay, I have some Chipotle for you at home.
Oh, you do?
I do.
Nice.
Okay.
All right.
I'll see you in a bit.
I'll probably be home before you call me back.
Okay.
Bye. Okay, bye.
Bye. Sorry. Okay. So I can kind of think here, -2. So -2 plus 3, that's a positive. -2 plus 1, that's a negative. -2 minus 1, that's also a negative. Again, I don't care what the actual numbers are. I only care if they're positive or negative, because then I can think positive times negative, that's a positive. So we're going to do that for all of the different test values that we chose. Okay, and you can see I did that. Then we make the sign chart. Okay, there it is. And we go back and we say, hang on, what was I looking for? Oh yeah, I wanted to know, when is this function less than 0? So that's negative. So I want to know, where is this function negative? Well, I can see that it's negative here, and I can also see that it's negative here. So I'm going to use those two intervals as my answer. And this is the solution. This interval notation is the answer to this polynomial inequality. Let's see if I want to show you. Yes, I want to do one or two more examples. So we'll look at those, and then I think you'll be good to go. You'll have seen kind of all the different things we can deal with. Okay, here's another example. X squared is less than or equal to 4x minus 2. Again, get 0 on one side, and then we need to solve this equation. Well, it turns out this one is not factorable, so that kind of stinks. So we end up having to use the quadratic formula on it, and we get this as our answers. What? Well, in order for us to really do this effectively, we're probably going to have to get decimal approximations for those. So that's what I've done here. So that when I put them on here and I go to look for my intervals, oh no, yeah, I'm okay. And I go to look for my intervals, I'll know what test points to choose. Okay, so I've selected the intervals, again using brackets because it's less than or equal to. So I chose, because remember this one was like 0.58, I chose 0. Then from 0.58 to 3.41, I just chose 1. And from 3.41 on to infinity, I chose 4. But notice that when we write our intervals and when we write our answer, we're going to use the exact value. We're just using those decimal approximations really to help us determine what test points I should choose. Okay. Again, then we put these numbers back into our inequality, or even into just this polynomial here. So, and looking for whether or not it's positive or negative. I assume that you all can plug numbers into an equation and figure out if the answer is positive or negative. So I didn't show all of that. And then I went ahead and just put those, translated those all onto the number line here. This is our sign chart. So we can tell, since we were looking for where it was less than or equal to 0, we're looking for negative. So it's negative only here in the middle. And so our interval that we're talking about for our answer is 2 minus the square root of 2 up to 2 plus the square root of 2. Okay. Now, sometimes you're going to run into a polynomial inequality that's already factored. And when that happens, it's thrilling. So we end up with, in this case, we have 2 minus x squared and then times x minus 7 halves. So we set each of these factors equal to 0, 2 minus x minus 7 halves. We solve each of them. So x equals 2, x equals 7 halves. Okay, so I put those on the number line. Here they are. Okay, now I'm looking at my intervals from negative infinity to 2, from 2 to 7 halves, and from 7 halves to infinity. And I choose test values in there, 0, 3, and 4. Okay, remember this is like 3.5, so 4. Okay, now I'm putting these values back into probably here. Okay, well, here's the thing. Any number I get in here, I'm going to square it, and any number squared is always positive. So the first set of parentheses you'll notice here is always just positive. So I really only have to worry about what's happening in the second set of parentheses. Well, 0 minus 3.5 is negative. 0 minus 3 minus 3.5 is also negative. And 4 minus 3.5 is positive. So positive times negative is negative. Positive times negative is negative. Positive times positive is positive. And we would make our sign chart. Oh, I didn't write the sign chart on there. Let me do that quickly. This one is actually kind of interesting. and I wanted to talk to you about it just quickly. So we look at our sign chart here. Notice, okay, because I don't want you to get lulled into the fact that, oh, it's always going to be alternate and go positive, negative, or negative, positive. It doesn't. Sometimes we run into a situation like this, okay? So negative, because it's not equal to, though, we have to still exclude the 2. It cannot be the 2. So we write this as our final answer. Okay, so even though the 2 intervals are right next to each other, we cannot include the 2 in our answer, so we have to do this. Now, this actually makes sense if you think about what we know about polynomials. The 0 of x equals 2 has a multiplicity of 2. A multiplicity of 2 tells us that the graph bounces off of the x-axis and goes back the other direction. So here's what's happening. This polynomial is negative, it's coming up, it gets to 2, it bounces and it comes back down and it stays negative. So it's actually negative that entire time, and then it somewhere turns around and it comes up and it actually crosses over. This 0 has a multiplicity of 1, so it has to cross, which makes it become positive. So I think that's kind of cool, just in light of all the things we know about polynomials and how this equation gets solved. So your assignment is here on page 366 and 367. Again, this is section 2.7. So let me write that on there. Section 2.7, page 366, 367. You're going to do 2 through 42 even. And yeah, they're all problems just like this. So that should not be awful, and hopefully it makes a little bit of sense for you. So I will be back with you all next class, so that's good. We'll kind of wrap everything up from section 2.6 and 2.7, and then we'll probably be getting ready to have a quiz over those things. So coming right up, and then we're going to be moving on. So have a great day, and I will see you soon.